Right. This one is called chain of responsibility. Yeah, that's a very nice one. So I'll write the name. This is called chain of responsibility. Yeah.
Yeah.
Cool. Right. So,
Just before you go on, and there was something quite similar. So, is that in the same vein as separations of concerns and division of labor?
say that again, please. So, separation of concern in division of labor. What does it mean?
Yeah. No, I'm just asking you. It's just these
Hmm.
words that I had, and because I've heard chain of responsibility,
Hmm.
division of labor, and separation of concerns. Are these all under the same banner type thing?
Kind of, yeah.
All
So,
right.
yeah, everything relates to each other, right? Because of all these principles, the separation of concern, single responsibility, and this and that, um, you know, um, messy class hierarchies and all that, polymorphism, composition, all that kind of relates to each other, because in the end, if we know these patterns, our code will look clean. That's the ideal thing. That's the final goal.
Yeah.
We need to write clean code, as well as it should be readable, and it should be very concise, and it should be straight to the point, rather than elaborating a lot. That's what all these patterns are talking about, right? And
Yeah.
and by just looking at the syntax for putting up a pattern, we learn something new from Kotlin as well, like type alias, how to pass a lambda, how to define a lambda, yeah, when I said pass a lambda as a parameter, into other functions, how functions can be, created and, used in the code and things like that, right? Yeah, and, high order functions and, how they are used in collections and this and that. So this gives us an opportunity to learn Kotlin as well. And it's a
Mhm.
good practice for me too, because yeah, I've been using Kotlin for a while, but this is a good practice for me. This is my playground, to use actual patterns so that, I can practice different concepts of Kotlin,
Mhm.
so to get my hands properly dirty. And then if you learn all the design patterns, we are actually learning the software development. That's what I'm saying, in all
Mhm.
aspects, writing Kotlin code, as well as how to see extractions and abstract things out, and how to create simple units and things like that. You know, so after we finish with the behavioral pattern, the reactive patterns are going to come. That's when we are going to look at coroutines. So that's another good one. So the next subject, this is just all Kotlin based. The next one, the reactive. The book talks about the reactive patterns too, which are used in the nowadays software development. Especially for Android development. So it's a good for us, Jason.
Mhm.
So
Yeah.
we can look at Kotlin, from this angle. How to use the mainly used patterns. So if you see a pattern which is getting in common, like are mostly used in places, we can call that as a pattern. And I haven't seen a book, talking about reactive patterns, and this book does, and it brings in the coroutines, as the example of writing code, so which is a good practice for us to, learn Kotlin as well as coroutines, and those patterns to be used, like how they are used in a view model, how you can write some code, in coroutine flow and things like that, in a way that it's used in solving problems.
Mhm.
So yeah, cool. Okay, so this chain of responsibility, right? It's something like, you take a responsibility. You could think of, maybe, yeah, maybe draw this. We could think of this as chaining the responsibility, actually, as the name says. Yeah. So what's this? No. Yeah. Yeah. Okay. So this one, right? So this one is like, so there are a couple of units, right? There are units, some classes or objects, we have, yeah. So they
Mhm.
all have to do something, right? So probably this needs to do something, right? Right. And probably this would also do something, yeah. And probably this would also do something, some actions, But then if this relies on what this gives as, so this might take an input, and this would give an output, right?
Mhm.
And the same for all of these guys. All these are functions. Imagine says, these are functions. When we say objects, you know, our functions are also objects in Kotlin, right? You know,
Mhm.
so yeah, so these functions, this function or function will have an input and output, right? If we think, I mean, this function is doing something and it's outputting something, and this function relies on this output, and it goes like this, and this function outputs this, and this function relies on that. We can chain all these guys together, don't we? Can we? Because I mean, this output will go here, this output will go here as an input. Yeah, that's what I'm trying to say. Anything this function does and outputs, and if that outputs become an input to this, because of this relies on the output of this one gives, we can chain these guys. See the chain? Because of this outputs becomes an input for this. Yeah.
Yeah.
Yeah. This output becomes an input for that. And the chain
Right.
goes like this. Yeah. Goes like
Mm.
this. Yeah. And we can call this as a chain of responsibilities. So anything this does relies on this. Sorry, anything this does relies on that, the other way, right? Yeah.
Yeah.
So that the chain can be you know, established like this, right? This is what this is talking about. So if components are doing something related and the outputs are, you know, dependent, the other, some other components are depending on other components' output, we can chain them. Yeah, cool. And let's see, you know, how we do that, right? Cool. So for that, right, the example is, you know, I mean, handling a request and response. Yeah, because you know, these are we can picture these as, you know, I mean, a request comes in, you get a response out, right? And that
Yeah.
response and the request which came in can become the input to this, right? So that this will do something with the request which originally came here and look at the response, and if it needs to modify, it modifies and pass it on, you know. So it's
Mhm.
basically going to get the request which this guy receives and the response here as the input, and pass it on. So they are all going to work with the request initially came in and the response finally which needs to come out. Yeah. So we can think of this as a request response thing. Yeah. Yeah.
Mhm.
Right. So in example, in our example, I'm thinking, you know. So
Yeah.
immediately, okay, so we can create the data classes request, right? So this request, let's say this could have username. A request would come with a username, right? I'm just making this up, right?
Yeah.
And
Sure.
yeah, request could be with the request could be with the email address or something. And then what else? Hmm. Yeah, just now, you know, let's keep this. And then the same, you know, we'll have a response. Yeah. So I can define what I need to deal with, right? And
Yeah.
the response would, of course, have some sort of an answer, no? Yeah. Yeah. That's the final response will have the answer. Yeah. For the, uh, as the final output, right? Yeah.
Right.
Final output here. Yeah. So for the
Okay.
request which we give in, we need to get the final output through this chain. Yeah. Yeah,
Oh
and this
yeah.
could yeah, this could be okay. So if you put more wordings here, so for the request came in, we could validate the request here, we could authenticate the request there, we could authorize the request here, and so on. And if they all pass their stuff they are doing, you know, we can return the response. Yeah. So yeah, yeah, that's how it's gonna look. The chain is, yeah, I agree.
Yeah.
Cool.
Definitely. Yeah. I can
Yeah.
see it.
Yeah, yeah, we can see that, right? Okay, cool. So normally we're going to look at like, I mean, how normally we would do, and we'll change it to using lambdas because this is Kotlin. This is functional, you know?
Mhm.
So let's see, I mean, how we would normally do. We would normally do, what we normally do is we will just create a function, right? Calling handle request or something. Bear with me. Handle request, which will give us the response for the giving request in, right?
Mhm.
Yeah. So we'll simply write the function like this and return uh, response, and we could give in an answer, something like that, right? But before
Okay.
this, you know, we will do all the stuff we need to do. So we'll validate, we will authenticate, oh, Okay, authorize and all that, right? Yeah. So we'll
Hmm.
do this is what we said as in, I mean, we wanted to do. So how will we validate? So we could probably check the, the stuff in the request, right? So the request dot username is not is empty. We can throw because then it's a error case, right?
Right.
Yeah, legal argument exception or something. Invalid or something. Yeah, yeah. We can throw. Otherwise, we can carry on, right? Uh, Probably we can say and request dot email. So we're validating the request, right? Dot is not empty. It's empty. Yeah. If both of these are empty, no, actually, or any of these are empty, we can invalidate the request, right? We can say the validation fails. Yeah.
Yeah.
If this one or that one is either those are empty because we expect both of them need to come through, right? We can throw it here, so it'll crash, right? It'll stop. Yeah.
Hmm.
If not, we can carry on. The next check. If how do we authenticate? Okay. So in order to authenticate, let's say, we can use some flags. So we can write the function here in the data class, saying is no is authorized user or something. Yeah. Just imagine, like, I mean, um this is the implementation, for authorizing the user, right? Authenticating the user, authorizing the user. So authenticate and the same, authenticate. Authorize and authenticate are different. You know that, right? Yeah. Authenticate said user is authorized user is authenticate user. So we can simply get the request, authorized authenticated user here. If it's not authenticated, we can throw. You see what I mean? You with
Yeah.
me? Yeah.
Hmm.
Same goes here for authorizing, but this time it's authorized. Yeah.
Yeah.
We can throw. Yeah. So we are simply, so I'm just putting a fake implementation here, but we'll actually, if it's our own, if it's in production, we'll probably write the implementation here, like, I mean, how to authorize a user. This might probably call the server here and, with the username, email, and, get the final response from server saying that, I mean, whether he's the response for authorizing and authenticating can happen here, could happen here, right? But we're just mocking it for now. I mean, just faking it, hard coding the values, saying the any request we create will be always authorized and authenticated by fixing the flags to be true. Yeah.
Hmm.
Right. So, and in order to validate the request, we validated it here. In order to authenticate, we check, the request authenticated method, what that's doing. If it's not authenticated as the request come in, we'll throw, and the same for the authorization, right?
Yeah.
If we pass all these gates, then we can finally give the response. Yeah, the response would be hello. Let's say we pick,
Successful.
yeah, hello, the request name now. Let's print the username. Yeah, hello. If you put the username as Thiru, or Jason, hello, Jason will come out here.
Yeah.
Yeah, and also say, yeah, okay, cool, fine. Okay, this is how we will normally do, right? So let's write the main function, and then let's create, yeah, let's create the let's get the response out. Calling this function will be handle request, and then the request will be, let's say we given the name, yeah, Jason. So, and the email address will be jason at gmail.com or something. Yeah, it's okay. Yeah. Yeah. So if we run this, and let's say, remember the also we can do, we can print this, no? When we return the response, we want to print it too. Print it. So it will print the response. Yeah. Let's see how
Hmm.
it works. Yeah. Yeah. Let's see how we're gonna see it. You're not really doing anything with the response, but unless, but we're printing it here, you know?
Okay.
Yeah. Cool. There you go. Responses. Hello, Jason, right? So that, we can probably print the answer. So it'll look much better now. So it'll just give us the answer up. Yeah, there you go. Hello, Jason. Yeah, because these are all valid. So let's say you have an empty string. What will it do? Ah, there you go. Boom. Illegal argument exception because of, our username is empty. Yeah.
Mm.
Yeah. So we can see how this goes, right? Yeah. So that's fine.
Yeah.
Cool. Okay. So how do we now use the functional concept? Because when we say functional in Kotlin, we have lambdas, right? Because we can use lambdas to pass them as parameters. So if we come back to our example here, we can think of this as, the request comes in and the response goes out. Yeah. And for this guy, it also needs the response and the request, the initial request came in, right? And if it has the response and the request here, it could work out what it should do. So this is the authorization bit, this is the validation, right? And then the next one does the same with the request and response come in, right? And if you also look at our code, what we have written, so here, everywhere, we're using the request, to return the response. Yeah. So all these guys are depending on the request coming in as the initial as the initial request. And finally, we are returning the response. So a little bit of mind shift here. So if we think of this in a functional way, the way we can think of this as also to picture or to put the chain of responsibility design pattern, we can think of this as how can we extract these out into their own units and chain the responsibilities, right? So each of those checks are going to come like their own function, right? And we're going to chain them up so that they will work together and by depending on each other's input and output to give the final response. That's the ideal goal. That's how we can chain it, right? So so that the code will become so concise. So this is a bit verbose. This is more like Java way, so you do one thing at a time, very declarative, right? Sorry, imperative, right? It's very imperative, right? You with me?
Mm-hmm.
Yeah. So how do we make it declarative? How do we use the lambda? So as we said, if we have a function, no, if we have something which gives us the request and the response together, yeah, we can pass this in between all these guys and we can work the way out, right? We can chain it so that everything will connect and work with it. So everywhere, if we give the request and response packed together into here, it will check the validation on the request, and if it's fine, it will return the response. So the whole thing will now pass to this. You with me? So that it will take the request and the response is also ready to be returned. If the request is not correct because for the authorization check it needs to check, it can error it there, or it will pass the request and response to this. Yeah. So ideally, we want the request and response packaged, packed in a way to pass it along, right? For that, we can use a lambda, right? The lambda will have an input and output, no? So we can define whatever this request and response thing in a lambda. So a lambda will look like, it takes a request and return response and return the whole thing as a lambda. So we will see it as, it takes a lambda and returns a lambda, which is this. This is what I'm talking about, request and response as a lambda. Request comes in, returns a response as a lambda, and we put that into another lambda as the output. Yeah, because of what we need to return still. So we take the lambda, which is request response, and return the request response, which is the same lambda. Yeah. Of course, the request will be validated every time or checked every time it's passed along. Yeah. So this is the ideal picture, using lambdas here. So it could be a little bit confusing, but I mean, when we write the code, you will see it, right? But the ideal thing I'm gonna try doing is, I'm gonna use a lambda which takes a request and response and return the same lambda with the same request and response. So we are creating a function which takes in a lambda and return a lambda. Yeah. Yeah. That's how we're gonna solve this, right? But to start with, you can see, no, if we go from top to bottom, this guy is only just returning a response because at the previous request we checked here, this is fine, right? So we can say to start with, if we want to extract this into the function, this needs to return the request and the response to start with so that it can go into this and that. Yeah. Let's see how that goes, how that's going to look, right? So to start with, I will start with a response. Yeah. So how will I do this? This will be the final response. Our lambda would be. Yeah. The final response would be a lambda. Yeah. But it will take nothing, but it will return a lambda itself, which will take wait, take a request and return a response. Sorry. Oh no, I should define the thing first, But this will be taking nothing and will return something that takes in a request and response. So
sorry, can you just start that again if you don't mind?
yeah, hold on. Yeah, I think I'm getting confused with these the signatures here. So hold on. So yeah, I'll do. What's happening there? Yeah. What's the problem here? I think it's using too many brackets or something, Takes the request as the input and returns a response. Yeah. Okay. Hold on. Yeah. And yeah, so this would be the first input, but everything is no. Okay, first input, and then this is the output. Yeah. Okay, but I can't. I don't think I can do this though. That's fine too. Okay. Yeah. Okay. See, I'm putting the types for the input and the outputs, right? To start with, all I care about at this level, all I care about is, it needs to return me the request and the response, right? The request in this case, the previous request, so that I can pass it along the way, So the type of this final response, lambda, would be, it doesn't take in anything, but it will return the output type as the request and a response lambda. So this is a lambda I'm returning. So the output is a lambda itself. You see, this is a lambda, no? But
yeah,
but the
looks
whole
a bit funny.
Yeah, the whole thing is a lambda, but the whole thing is a lambda, but it's returning a lambda. The output is itself a lambda. Yeah, that's how we're seeing it. This is the maximum you can go with lambda stuff, After this, man, we'll be cool with lambdas. This is the maximum anyone can confuse you with lambdas, using lambdas, because it's taken in. It's the type of the lambda is returning a lambda. lambda inside lambda, but it's easy to see, right? I mean, it doesn't take in anything input as the type of this lambda I'm defining here. This is the input and this is the output, right? Yeah.
Yes, right.
Yeah, that's why I put them into brackets. This is the input, this is the output, right? So the input, it's not taking anything, so it's void. Yeah, it's nothing. Yeah, the input doesn't take in anything, but the output, it's giving you the type, giving you a lambda out, because of the type of what we are returning, or what we are outputting is a lambda itself, and that lambda takes in an input as request and returns you the response.
Right.
Yeah. Okay, so now we're going to implement it. How do we implement this? So it doesn't take in anything, but it needs to return a lambda. So immediately it will have the inside lambda in here, right? But that inside lambda will take a request, yeah, and it needs to return a response. So if we do this, you'll be fine. Yeah, you see? Yeah. So, but at the moment it's not using the request, but the request will be, the final answer will be like something like this. No, that's what we said, as we want to return as the response. Yeah. So the response string will be something like this. Yeah. So it takes. So what I've done is, so I've created a lambda, the whole lambda, because this whole thing is a lambda, right? But what that lambda is doing, it's returning a lambda inside. So I've created another lambda which is returned here. Yeah, this is the output. But that output takes in an input and output as request and response. So it takes the input as request and the response coming out as response. That's it. Yeah. So that's my final response working with the request, right? So this is what is going to get returned, because that's my output according to this.
Right.
Yeah. Okay. So now if we create the next one, which is the authorization. Yeah. So the authorize will be now should take in something. This is the lambda itself and should output something. But in our case, it's going to take this, which is what's coming out from the previous one. Yeah. And it's going to pass on the same thing. Yeah. So the authorize will get what this one is returning, because of it needs to access the request to do something with it, and it will pass back the same request response, so that the output come out as request and response. So the next one will just chain up and work with the request. You see? Yeah, that's the idea here, right? But what's wrong? Sometimes this I'm missing a bracket. That's why. Extra bracket here. Huh? Oh, sorry. I'm always making this mistake. Right. Okay. So what is the input here? This is my input. This is my output for this function. Yeah, authorize. But what's the input here?
This the
Yeah.
validation from the first one.
Oh no, just tell me the type though. What's the input?
Oh, the request. Yeah. Oh, it's the lambda.
Yes, exactly. That's what I want to see. That's what I want to hear from you too, because that's where you need to understand it. So it takes in a lambda now. The input is itself a lambda. Yeah.
Yeah.
And now the output is for the whole. So the main lambda's output is this, and that is also a lambda, which is taking the request and the response. Yeah.
Right.
Yeah. So hey, Charles,
Hello.
Hey, Charles, how are you, bro?
I'm fine. I'm
Yeah. Oh, no, it's okay. We're just talking about the next one today, which is called chain of responsibility. And I'll explain to you after this. So we're going to finish this bit, So, yeah, just have a look what we're doing now. I mean, then I'll explain that what this is about, when we summarize it, right?
okay.
Cool. Yeah, thanks, man. Okay, so this authorized lambda has the input as a lambda and output as a lambda. So the input, we're going to get the lambda here, right? So the so the input will be it's a lambda itself, you know. So let's call this something, you know. See, that's why it's even showing you it is a request returning response lambda, right? Let's call this as next or something for now, because that's what we're going to call it as, you know. We're going to pass it to the next, you know. But then it needs to return a lambda, yeah, which is the output here, yeah.
Right.
So that's why I'm creating a lambda here, which is actually going to take the request. I'm going to work with that and going to return the response. So in our case, what do we do with the request for authorization? This is what we do. Yeah. So we can copy that. We can copy that. And we can say if it's that, error it, or else return the response. Else give us the response. No. No. Otherwise, we have this lambda and execute that one with the request. Yeah. Yeah. It's a bit confusing, but all we are doing is we receive a lambda from the previous one because of that outputs a lambda, and that's what we're receiving here. And we are outputting a lambda, which is the same kind of type, which is getting a request and response. So here what we are doing is we receive the lambda, which is that lambda, and then we need to return a lambda here as well, you know, which is the same.
That's a variable type, yeah?
Yes, yes. So it takes, so this is where I'm creating a lambda to be returned. You know, this is my output actually. This is my output lambda, which is this. This is my output, right? So I'm creating a lambda. So that's the one which is going to get returned to the next one, but it takes a request and response. So it takes a request, and in order to give a response out, I can call this with a request because of that itself take the request and returns the response. So I'm just, you know, taking the input and executing it here so that it will give me the response out. Yeah, this is how I'm chaining it. See, I'm chaining whatever the thing which is coming out from this into this, you know?
That else looks a bit funny. After the else, that next, it looks like a function.
Yeah, no, because this is already a lambda, right? Because of the input is a lambda for me, right? This is a lambda.
Oh.
We can define the type here as well. No. Sorry. No, if you don't have
No, I can understand that, but I thought that was a variable, just a variable to hold.
No, I'm just saying, you know, this is the request. Okay. Maybe we could say request lambda or something.
Yeah, no, not the name. I meant like what it does. It just holds the value, isn't it?
Yes, exactly. No, it's not really holding, but then this is a lambda. We want to execute it.
Oh.
When this output gets executed, when the whole thing, you know, which is the output, which is the whole lambda here, when that gets executed, we are going to grab the input and, you know, put the request in so that it'll give us the response out. Because ideally, we are chaining this lambda into this so that it will give us the last output, which is the response, which this is returning. You know, you see that?
Say that again. It'll give us the last.
Yeah, because of the idea. Yeah. So when we wrote this, right, this function, we wanted to ideally give us the response out. No. What this function is doing, this lambda is doing, it's not taking anything, but it's returning a request, and the response is a lambda, right? And that's what we have defined here. Yeah, we said this is our output, which is a lambda, and we have implemented it saying if it takes a request, it will return me the response. Right. So if we now use this, this will come into this. You will see how I will train it, but you know, this will need the previous request response lambda as the input, to chain up, right? And it will return this. So whatever the response we are returning here is the one we need to return here too.
Okay.
Because that's our final response, because that needs to come out, right? So this lambda should give us the response by executing this lambda by giving in the request. Because I mean, for this lambda to execute, you need to put in a request and it'll give you the response out. No, that's what I've just done here. That's what I've done here. So whenever we execute this lambda, it's going to return this, right? And when that's get executed, it will execute this code, isn't it?
Yeah.
The request given, it will check what is that request and blah. If it's fine, it will execute this one, which is this lambda, which is actually returning the final response from that, because that's what we are going to, this is output as we are going to use it into this input. Remember, we said anything this returns, which is this output, will become the input to the other function. That's how we chain this, right? So anything this returns will become this input. So that's why I'm keeping the output of this type is the same here as the input of this one.
Right. Yeah.
Is what I mean?
Comes out of one and goes into the other.
Yes, correct. To simplify this, we can use the type alias. Remember, because there is a lot of request response used as types everywhere. You know, so I can type alias this. You know, so I can say, what is it? Handler. No, how can I call this? Handler. No, handler. Let's call it handler then. No, which is this handler. So I can, everywhere I have this input output, I can call this as handler.
All right.
Now this is a handler. It takes in a handler and it will return a handler. Oh, no, it takes in and it's returning out a handler. Yeah, and it goes like that. Yeah, this is also a handler, but I mean, it's, yeah, you know,